let's look at the segment addition postulate for the following. So we have 3 line segments. We have LM is 1 line segment, which is 3x plus 8. MN, which is another line segment, which is 2x plus 5. And LN, which is another line segment, which is 23. Before we even begin to look at this, though, we have to look up here. Suppose M is between L and N. So what I want to do before I even begin to try to solve that problem is I'm going to draw a line segment. And I know M is between L and N. So I'm going to put L here, N here, and M somewhere in between. I intentionally did not put it in the middle because I do not know where M is. Okay? So we're going to find the lengths of line segment LM, line segment MN, and line segment LN. So line segment LM is this segment right here. Segment MN is this segment right here. So it's helpful to draw the picture and label. And then we have line segment LN. Well, line segment LN, remember, is from here all the way over to here. So I'm going to just label what I wrote in purple. So that's really this whole thing right here. Okay, that's my LN. So let's see what information they give me. They tell me that line segment LM is 3x plus 8. So I'm going to write that right here. That's what that line segment distance is. The line segment distance MN is 2x minus 5. So I'm going to write that right there. And then the entire segment is the length 23. So I'm going to write that right there. Okay, actually I'm going to write it down beneath so we can see that a little bit clearer. I'll erase that. Okay. So looking at our picture, we know that from the segment addition postulate that if we take this segment and we add this segment, we're going to get the entire segment. So what does that mean? Put a big addition sign right here. So if I add those 2 segments, I get the entire segment. So let's write this out. I think I'm going to write it over here. 3x plus 8 plus 2x minus 5 equals 23. So this was my first segment. This was my second segment. And altogether it equals my whole segment. Okay, now we get to do some algebra. So we can only add like terms. So this is a 3x. I can't add that to an 8 because this has an x in it. That doesn't. But here's another x, a 2x. So I can say, let's rewrite this to 3x plus 2x. So those are like terms. I just simply brought that one over here. Plus 8 minus 5 equals 23. So I'm going to add my like terms. So that's 5x. Add my like terms, plus 3. And that equals 23. Okay. So now what I need to do is I need to solve for x. Now that I've grouped everything together. So the first thing I'm going to do is I'm going to subtract 3 from both sides of the equal sign. And if you struggle with this, you may want to just put a little line down here to keep everything on one side of the equal sign equal to the other. So that means I have 5x. This is 0. 3 minus 3 is 0. And 23 minus 3 is 20. Since the 5 is being multiplied to the x, I have to divide. I'm going to move this up. So I'm going to divide 5x by 5, and I'm going to divide 20 by 5. 5 divided by 5 is 1, right? So that gives me 1x equals 20 divided by 5 is 4. So x has to equal 4. Is that my answer? Well, let's go back and see what the question asked. The question is not asking me to find x. The question is asking me to find the lengths of this and this. But remember, I discovered that x equals 4. So I simply have to now substitute my 4 in for x, and I can find the length of each segment. So this is 3 times 4 plus 8. That's line segment's length. And this line segment length, MN, is 2 times 4 minus 5. So now I have to do, remember my PEMDAS, 3 times 4 is 12, plus 8. So this line segment is 20. Line segment LM is 20. So I'm going to write that over here. The distance of LM equals 20. Okay, so those of you who are pretty savvy can say, well, if this is 20 and this is 23, then this must be 3. Well, let's see if that's so. 2 times 4 is 8 minus 5. 8 minus 5 is 3, and that's exactly right. So MN, the distance between M and N, is 3. That is my answer, because that's what the question was asking for.